Triangle inequality theorem allows us to determine if three given sides of a triangle can actually create a triangle. Completing the chart below with either exists or not possible. If A plus B is greater than C, where C is the largest side given out of the potential three sides of a triangle, as long as the sum of the two smaller sides is greater than the third side, then yes, the triangle will exist. However, if the sum of the two shorter sides is equal to the third side, or the sum of the two sides is less than the third longest side, then it is not possible to create a triangle from these instances. Where A plus B is less than C, we get this instance where our two legs don't intersect, they can't touch, and they don't create that third vertice that we need in order to create a triangle. In our first instance, if B equals C, then we have the side C, but A and B would lie directly on top, giving us a straight line as opposed to a triangle. The converse of the Pythagorean theorem allows us to determine whether a triangle is acute, right, or obtuse. Completing the chart below with acute, right, or obtuse, we look in our first instance. If c squared equals a squared plus b squared, this is the Pythagorean theorem, then we in fact have a right triangle. In our middle case, if c squared is greater than a squared plus b squared, then we have an obtuse triangle. And lastly, if c squared is less than a squared plus b squared, then we have an acute triangle. Applying both of these scenarios to questions 2C through 2F, we're going to determine whether the side lengths can actually create a triangle via our triangle inequality theorem. And if yes, we will classify the triangles as obtuse, acute, or right using, again, 2A and 2B, triangle inequality theorem and converse of the Pythagorean theorem. So let's go ahead and set up on 2C. In order for the triangle to exist, the sum of the two smaller sides must be greater than the larger side. So 12 plus 16 must be greater than 23. 28 is greater than 23, so yes, we can create a triangle. Now we must classify what type of triangle it is. So we'll set up the Pythagorean theorem. We need to determine how the c squared value relates to the sum of a squared plus b squared. Substituting in our known value. We have 23 squared and 12 squared plus 16 squared. Simplifying, we have 529 and 400. 529 is clearly greater than 400. Therefore, our c squared value is greater than a squared plus b squared. Looking at our chart, this means that we have an obtuse triangle. 2D, starting off the same way. We must check that the sum of the two smaller sides is greater than the sum, or the larger side. In this case, 8 plus 15 must be greater than 17, or 23 must be greater than 17. This is true, meaning yes, we can create a triangle. Now we have to classify it. We will again use the Pythagorean theorem and see how the c squared value relates to a squared plus b squared. Substituting in our known values and simplifying, we get 289 and 289. These values are equal, meaning that the c squared value is equal to a squared plus b squared. And looking at our chart, this means we have a right triangle. 2E and 2F will follow suit. A plus B must be greater than C, the largest side. A plus B must be greater than the largest side. One note, please make sure we're always looking to see that the numbers are, in fact, going in increasing order. Sometimes the numbers can be rearranged, so do not go on autopilot and just think first number is always A, second number is always B, and third number is always C. The C value is the largest of the potential given sides. Sometimes I will mix this order up, so please be mindful as we're doing this. 12 and 17 are the two smaller sides, therefore they're A and B, and 20 is the largest, so it's C. 15 and 16 are the smaller sides, so they are A and B. 32 is the largest side, so therefore it is C. Back to 2E, we're substituting our known values. And simplifying. We have 12 plus 17 is greater than 20, or 29 is greater than 20, meaning yes, we can actually create a triangle. Now we will go ahead and classify it. We need to see how the c squared value relates to a squared plus b squared, or 20 squared related to 12 squared plus 17 squared. 400 and 433. 400 is less than 433, meaning that our c squared value is less than a squared plus b squared, meaning that we have an acute triangle. Now, 2F, substituting our known value, 15 plus 16 must be greater than 32. We have 31 must be greater than 32. This is not true, so no, the triangle is not possible. Therefore, we cannot further Continue with this problem. We cannot classify a triangle that does not exist, and we are done.